Hello dear students, in this video we will study graph of different trigonometric functions. So we are going to start from sine x, sine function. We will have a graphical representation of sine function. This is our function y is equal to sine x, and we will substitute different values of x with the interval of 30 degree, 30, 60, 90, 120. So we are starting from 0 and we are ending at 360, and we are taking intervals of 30 degree. We know that sine 0 is always equal to 0 and sine 30 degree is equal to 0.5, and similarly we can calculate these values using calculator. Sine 60 is equal to 0.86, 0.87, and sine 90 degree is 1, sine 120 is 0.87, and sine 180 is, we know that sine 180 is always 0, and sine 210 will be equal to minus 0.5, and sine 270 is minus 1, and sine 330 is sine 330 is minus 0.5, and sine 360 is again 0. So if we plot these values over here, this is our first coordinate, and then at x is equal to 30, the value of y is 0.5, and sine 60 is equal to 0.87. This is 0.87, and this is minus 0.87. So sine 60 is 0.87, and sine 90 is equal to 1. Sine 120 is again 0.87, and sine 150 is 0.5. Sine 180 is 0. Sine 210 is minus 0.5. Sine 210 is minus 0.5. Sine 270 is minus 1. Sine 330 is minus 0.5, and sine 360 will be equal to 0. And if we join these coordinates, we will have this type of graph. So this is graphical representation of sine function, and similarly we can have graphical representation of cosine function. If you have a function y is equal to cos of x, we know that cos 0 is always 1, and cos 30 is 0.87, and cos 60 is 0.5, cos 90 is 0, cos 120 is minus 0.5, minus 0.5, and cos 180 is minus 1, and cos 210 is minus 0.87, minus 0.87, and cos minus 1, cos 270 will be equal to 0, cos 330 will be equal to 0.87, and cos 360, again cos 360 is 1. We will draw the graph of cosine function with red marker. First of all, at 0 degree the value of cos is 1, and at 30 degree it is 0.87, at 60 degree it is 0.5, and at 90 degree it is 0, and at 120 it is minus 0.5, at 180 it is minus 1, here it is minus 1, and at 210 it is minus 0.87, and and at 270 it is 0, at 330 it is 0.87, like this, and at 360 it is 1. So if we join these coordinates, we will have this type of graph, like this. This is graphical representation of cosine function, and we can make a general formula for graphical representation of sine and cosine function. This function can be written as 1 into sine x plus 0. Now this is, if we have 0 here, then y is equal to 0 will be our central axis. For example, we have drawn graph of sine function and we have seen that y is equal to 0 is our central axis, and this is amplitude of function. Amplitude means the distance, the perpendicular distance between mean position and extreme position. This was mean position and this was extreme position. We have seen that the distance between mean and extreme position was 1. If we have a function like y is equal to 2 into sine of x, our amplitude will be doubled, like this. Here we have 1 and here we have 2, like this. Our amplitude will be doubled. I'm making this in a dotted line, like this, if we have 2 as a coefficient of sine function. So we can make a general formula like this: y is equal to a into sine of x plus b, or y is equal to a into cos of x plus b. If we have this type of function, then y is equal to b will be the central axis or mean axis of our graph, and a is basically the amplitude or height of the function. Like when we have drawn the graph of y is equal to 2 into sine of x, we have seen that amplitude of graph of this function was 2, and in this case when coefficient is 1, amplitude of graph of this function was 1. So we can draw graphs of sine or cosine function using these formulas.